To start looking at factoring, I want to first look at distributing. If we have the problem 4x squared times the quantity 5x plus 3, we need to distribute the 4x squared to both the 5x and the 3. Now we have 5x times 4x squared plus 3 times 4x squared. Multiplying these like we learned earlier, we get 20x cubed plus 12x squared. Since we saw the problem at the beginning, we already know that both the terms in 20x cubed plus 12x squared have a 4x squared as a factor. That means 4x squared is a common factor. But let's look at the two terms closer to see why. If I factor the coefficient from the first term, 20, into 2 times 10, I see that I could factor 10 again into 2 times 5. So 20 equals 2 times 2 times 5. If I look at the whole term, 20x cubed, I can expand the x cubed into x times x times x to write it as 2 times 2 times 5 times x times x times x. For the second term, 12x squared, I can factor 12 into 2 times 6. And I can see that I could factor 6 more into 2 times 3. So 12 equals 2 times 2 times 3. If I look at the whole term, 12x squared, I can now write it as 2 times 2 times 3 times x times x. Now that we have both terms factored completely, let's look at which factors they have in common. They each have a 2, another 2, an x, and another x. These are each common factors. But if we take all these and multiply them together, we get the greatest common factor, 4x squared, which is what we originally distributed. Identifying this is the key to factoring out a GCF. Another thing to notice is what was left of the terms after we took out the common factors. 5x and 3, which were the two terms in the original set of parentheses. 5x plus 3.